Bismillahirrahmanirrahim. Assalamu alaikum, ma'am. Hope so. You will be fine. My name is Jawad Ahmad and roll number 60, BSIT section A. My topic for the presentation is concurrency control. Concurrency control means that to enforce isolation through mutual exclusion among conflicting transactions. Means ke it's enforce the isolation between the two occurring transactions which are conflicting each other. To preserve database consistency through the preserving execution of transaction, to resolve read-write and write-write conflicts. Example, in current execution environment, if T1 conflicts with T2 over a data item A, then the existing concurrency control decide if T1 or T2 should get the A, and if the other transaction is rollback or waits. Locking is an operation which secures concurrency control. First of all, it's permission to read or permission to write a data item for a transaction. Example, lock X, data item X is locked in behalf of the requesting transaction. Unlocking is an operation which removes these permissions from the data item. Example, unlock X, data item X is made available to all other transactions. Lock and unlock are atomic operations. Optimistic concurrency control. Optimistic concurrency control (OCC) is a concurrency control method that assumes that multiple transactions can complete without affecting each other, and that therefore transactions can proceed without locking the data resources that they affect. Before committing each transaction, verifies that no other transaction has modified its data. If the check reveals conflicting modifications, the committing transaction rollbacks. Optimistic concurrency control was first proposed by H.T. Hung. OCC transactions involve these phases. Begin. Record a timestamp marking the transaction's beginning. It's mean that it keeps a record of timestamp marking the transaction beginning. For example, from where the transaction is start with which data items, it keeps the record. And then the other is modify. Read and write database values. Validate, check whether other transactions have modified data that this transaction has used, read or wrote. Always check transaction that completed after this transaction's start time. Optionally, check transactions that are still active at validation time. Comment rollback. If there is no conflict, for example, there is no conflict occurring between two transactions, it make all changes part of the official state of the database. If there is a conflict, resolve it typically by aborting the transaction. If in comment and rollback, if there is no conflict, then it make it possible to change the part of the official state of the database. If there is a conflict, means if there is a conflict arising in between two transactions, then it helps in resolving it typically by aborting transaction, by aborting one transaction for another, or if we take transaction A and transaction B, and there is a conflict between transaction A and transaction B, then it will typically abort A or B for the other. Pessimistic concurrency control or pessimistic locking is called pessimistic because the system assumes the worst. It assumes that two or more users will want to update the same record at the same time, and then prevents that possibility by locking the record, no matter how unlikely conflict actually are. The lock are placed as soon as any piece of the row is exceeded, making it impossible for two more users to update the row at the same time. Furthermore, we have another Subtopic in concurrency control, which is two-phase locking technique. Essential components: two lock modes, shared read and exclusive write, in which we have shared lock is a read lock and exclusive is a write lock. Share mode: share lock X. More than one transaction can apply share lock on X for reading its value, but no write lock can be applied on X any other transaction. In share lock, if we have transaction A, B and C, then then the B, if a data item is busy with if a data item is assumed by A, then the C and D or B, C, D, these transactions will apply a share lock on reading its data value, its data item, which is assumed by transaction A. They can only apply a share lock, which means read lock. They will never apply write lock because it will crash the system, the transaction system. Exclusive mode. Exclusive mode. Write lock X. Only one write lock on X can exist at any time, and no share lock can be applied by any other transaction on X. If transaction X have a data item, then the other transaction will never applied exclusive mode or write lock on X because it's not allowed by the system or the transaction system. Types of lock. Binary lock. We have a binary lock can have two states or values, locked and unlocked. Lock item and unlock item operation must be implemented as individual and divisible units. For example, interleaving is allowed once a lock or unlock operation is started until the operation terminates or the transaction waits. Two-phase locking technique in binary lock. Our database requires all transactions should be well formed. A transaction is well formed if it must lock the data item before it reads or writes to it. It must not lock any already locked data items, and it must not try to unlock a free data item. The following code perform the lock operation. If lock X is equal to 0, item is locked, item is unlocked, then lock X, lock the item, else begin. If it's not lock or unlock yet, then wait. If it's locked, then it will allow the other transaction to wait for until lock X is equal to 0 and the lock manager wakes up the transaction go to B end. This code will perform the lock operations for a data item. The following code, this code will perform the unlock operation for a transaction. If transaction A has a data item which assume a data item, then this code will perform the unlock operation for its data item. Share lock, exclusive lock. The preceding binary lock scheme is too restrictive for database items because at most one transaction can hold a lock on a given data item. Several transactions should be allowed to access the same item X if they all access for reading purpose only. However, if a transaction is to write an item X, it must have exclusive access to X. Share lock, multiple lock mode, also called share lock, shared, exclusive, or read-write lock is used for this purpose. There are three locking operations: read lock X, write lock X, unlock X. A lock executed with an item X, lock X, now has three possible states: read locked or shared lock, write locked or exclusive lock, or unlock, the third one. The system must enforce following rules. A transaction T must issue the operation read lock X or write lock X before any read item X operation is performed in transaction. A transaction T must issue the operation write lock X before any write item X operation is performed in transaction. A transaction T must issue the operation unlock X after all read item X and write item X operations are performed in a transaction. This program or code perform the read operation. If lock X is equal to unlock, then begin. If a transaction lock data item X, then it will allow unlock, then begin lock X, read locked, no of reads, number of reads 1, end. Here a transaction is terminated with this end. Else if lock X read locked, then no of reads X, number of reads X plus 1. Else begin wait until lock X is equal to unlock and the lock manager wakes up the transaction go to be, that's in. And furthermore, this code perform the write operation. If lock X is equal to unlock, then lock X write locked, else begin wait until lock X is equal to unlocked and the lock manager wake up the transaction go to be, end. The following code which I highlighted, this code perform the unlock operation. If lock X is equal to write locked, then begin lock X unlocked, wake ups one of the transaction if any, end. Else if lock X is read locked, then begin number of reads X minus 1. If number of reads X is equal to 0, then begin lock X is equal to unlocked, wake up one of the transaction if any, end. Lock conversion. Lock upgrading existing read locked write lock. If Ti has a read lock X and Tj has no read lock X, I isn't equal to or is not equal to j, then convert read lock X to write lock X, else force T1 to wait until Tj unlock X. Lock downgrade. Second conversion in the lock conversion is lock downgrade. Existing write lock to read lock. Transaction I has a write lock on X. No transaction can have any lock on X. Convert write lock X to read lock X. And furthermore, two-phase locking. Locking growing B, unlocking shrinking. Locking growing phase. Locking phase means growing phase. A transaction applies locks read or write on desired data item one at a time. Unlock shrinking phase. A transaction unlocks its locked data item one at a time. Requirement for locking growing and unlocking shrinking. For transaction, these two phases must be mutually exclusively. That is, during locking phase, unlocking phase must not start, and during unlocking phase, locking phase must not begin. Uh, for these two phases, the requirement is that it should be mutually exclusive. That in one phase the unlocking should not be start in unlocking, and in the other unlocking phase should not be start in the process of locking begin. Two-phase locking techniques. Two-phase locking generates two locking algorithms, basic and conservative. Conservative prevents deadlock by locking all desired data items before transaction begins execution. Basic transaction locks data items incrementally. This may cause deadlock, which is dealt with. Strict. A more stricter version of basic algorithm where unlocking is performed after a transaction terminates, commits or aborts and rolled back. This is the most commonly used two-phase locking algorithms. Deadlock. Deadlock is also a type of lock. A deadlock is a situation in which two computer programs sharing the same resource are effectively preventing each other from accessing the resource, resulting in both programs ceasing to function. The earliest computer operating system can only run only one program at a time. Deadlock prevention. Deadlock basically means that if a data item X is needed to two transactions, transaction A and transaction B. The both transaction wants to read or write the data item X. Then deadlock occurs here. Which transaction should get the data item X first? If we apply first in or first out rule, first in first get rule, then the transaction which apply for write or read first from the order, then it will get the item. In deadlock have also prevention. A transaction locks all data item it refers to before it begin execution. This way of locking prevents deadlock, since a transaction never waits for a data item. The conservative two-phase locking uses this approach. A couple of minutes before I talk about this, the conservative two-phase locking use this approach. For deadlock prevention, we also use this conservative two-phase locking technique. Deadlock detection and resolution. In this approach, deadlocks are allowed to happen. The scheduler maintains a wait for graph for detecting cycle. If a cycle exists, then one transaction involved in cycle is selected victim and rolled back. Furthermore, a wait for graph is created using the log table. As soon as a transaction is blocked, it is added to the graph when a chain like T transaction I waits for transaction J, waits for transaction K, waits for transaction I or transaction J occurs. Then this creates a cycle. One of the transaction of the cycle is selected and rolled back. So this was my topic for the presentation, concurrency control. I hope I try my best and the best possible path to ensure my marks in the exam. Thank you, ma'am, for giving us this opportunity, and I hope you will admire our hard work, inshallah. Stay blessed, ma'am. Assalamu alaikum. Thank you.